Hope you're having a good Thursday. I'm sorry I can't be there today. You know that I really like your class, and it just sucks that most of the stuff I do happens on Thursdays. But we'll still get some notes done today, so hopefully we'll be able to catch up to the other classes that I have. So, if you guys remember, last class we started with this page out of the packet because I couldn't make copies of the whole packet. And we compared what Sadie and Micah did when they solved the problems. Then you guys split into groups, and some of you solved the problem the way Sadie did, some of you solved the problem the way Micah did. In our last class, I had you guys answer question A, where you answered what was similar and what was different about Sadie and Micah's work. After you guys tried out the problem, I think you're ready to answer questions B and C, asking which one had a valid solution, or did both of them have valid solutions, and which method did you think was better? Which one do you prefer? There's no wrong answers for question C because it's all about the way that you liked better after solving it yourself and hearing how the other group solved the problem. So take a couple minutes to answer those questions. Pause the video, and when you're ready, press play, and we'll move on to the back of the sheet to do some notes. In this lesson, we're learning a new method of solving systems of equations that you didn't do last year in 8th grade. And it's called the elimination method. This method is really good when we have equations that are in standard form, like the two equations that you guys see here. That's where it's not in slope-intercept form, it's not solved for one of the variables, but both variables are just part of the equation. If we wanted to use substitution for this, we would have to take those extra steps of solving for one variable, and I know that's something that we struggle with a bit. So this will hopefully get rid of the need to do that and make it a lot easier for you guys. What we're looking for in a problem like this is when the same variable has the same number in front of it but opposite signs, like we have with the y's here. If you remember, if there's no number in front of a variable, it's the same as a y. So it's like we have positive 1y and negative 1y. And that means that this is a perfect problem to use elimination on. Once we've found those variables that have the same number and opposite signs in front of them, we're going to go ahead and add the two equations together. So we just add the corresponding values in each place in the equation. So we'll start by doing 7 plus 2, which is equal to 9. Then we're going to add the positive 1y and the negative 1y, which is going to equal 0, which eliminates y as the variable. Then we do 1x plus 2x, which is going to give us 3x. So we have 3x plus 0 equals 9. Now, adding 0 doesn't really do anything for our equation, so we can eliminate that 0 and just write it as 3x equals 9. Now, this is a really easy equation to solve. All we have to do is divide each side by 3, and we'll find out what x equals. X equals 3. See, that was a lot easier of a way to find x than all the steps we would have had to do to use substitution. Now, of course, we're not done our problem yet if we just found x. We still have to find y. Now we're going to use those substitution skills to plug 3 in for x in one of our original equations and solve that for y. So when I write this equation, originally it was x plus y equals 7. I'm going to replace the x with 3 because I know that x equals 3. And then I'm going to go ahead and solve the equation for y. So to solve this, I want to subtract 3 from each side using my inverse operations to get rid of a positive 3. and I'll be left with y equals 4. So that was a really simple way to get my ordered pair and get my solution for the system of equations. So my solution is 3 comma 4. And if you guys remember, that's the place where the two lines intersect if we were looking at a graph. Now I want you guys to look at the 3 questions on the left-hand side. We're going to talk about those. Why does it make sense to eliminate y in the system of equations? Because y has the same number in front of it, but opposite signs. One is positive, one is negative. So that tells me that they will easily cancel out. That's what we're going to look for in every problem that we do like this today. Is the solution to the system of equations just the value of x? We know the answer to that is of course not, because we have to get an ordered pair. So we have to find y, like we did in the equation when we plugged that x value back into the original equation. Now the last question, how does adding the equations help you solve the system? When we add the equations, those two opposite values cancel each other out, and we quickly eliminate one of the variables. By eliminating one of the variables, it makes it a lot easier to solve for the other variable. Hopefully you copied that down and you're ready to move on to the try it problems. If not, go ahead and rewind and pause the video so you can get those notes copied down. We're going to solve these try it problems together because I gave you a worksheet that'll help you practice, which has 10 problems like these. So I want to just make sure that we really understand how to do this. In problem A, I have positive 4y in one equation and negative 4y in the other. So that's my clue that this is a good elimination problem and that I'm going to be eliminating y as my variable. Now that I identified which variable I'm going to identify, I'm going to go ahead and add the two equations together. So again, I'm going to start with 2 plus 3 and get 5. Then negative 4y plus positive 4y is going to equal 0 and eliminate y as a variable. And I'm going to do 2x plus a negative x, which remember that's 1x. And plus a negative is the same as subtraction. So it's like 2x minus 1x, which gives me 1x. We can eliminate the 0, so we get x equals 5. Super simple getting x with this equation. Now that we found x, we need to plug it into one of the original equations. It doesn't matter which one you plug it into. And we're going to solve for y. So when I plug 5 into the first equation, I get 2 times 5 minus 4y equals 2. I'll do my multiplication first with my order of operations. 2 times 5 equals 10 minus 4y equals 2. I'm going to use my inverse operations to get rid of the 10. Since it's positive 10, I'm going to subtract 10 from each side. And I'll be left with negative 4y equals 2 minus 10, which is negative 8. Now to get the y by itself, I just need to divide both sides by negative 4. Negative 8 divided by negative 4, and negative divided by a negative is going to give me a positive 2. So my ordered pair for this equation is 5, comma 2, and that's the spot where the two lines would intersect each other on the graph. All right, one more equation, or system of equations. We're going to move on to problem B. In problem B, our variable with the same number but opposite signs is x, because I have positive 2x and negative 2x. So I've identified those. This is a good problem for elimination. I'm going to add them together. So 1 plus negative 6 is the same as 1 minus 6, so I get negative 5. 3y plus 2y is 5y. And 2x plus a negative 2x is 0. Eliminate the 0, I get 5y equals negative 5. I'm going to divide both sides by 5, and I'll get y equals negative 1. Now, just like I did with x in the previous problems, I'm going to take negative 1 and plug it in for y in one of the equations. So let me rewrite this. 2x plus, oh wait, it's 3 times negative 1. So 2x plus 3 times negative 1 equals 1. When I do that 3 times negative 1, it's actually going to give me a negative 3. So 2x minus 3 equals 1. My inverse operations are going to tell me to add 3 to both sides. And I get 2x equals 4. I divide both sides by 2. And I get x equals 2. My ordered pair for my solution is going to be 2, comma negative 1, which again is the spot where the two lines would intersect on the graph. So now that you guys have seen the example and the try-it problems and hopefully have these copied into your notes, I would like you guys to try the worksheet that the substitute will give you. The worksheet has 10 problems just like the ones that you saw. I want you to practice all of them and show all of your work. You won't get full credit unless you show all of your work. This worksheet will count as a summative grade when I see you again on Tuesday. So if you finish it before the end of class, turn it into the substitute. Otherwise, give it to me on Tuesday so you can get full credit for the assignment. I hope you guys have a wonderful 4-day weekend. Hopefully I'll get to speak to some of your parents and say nice things about you tomorrow. And I will see you on Tuesday.